All right, we're going to look at different functions in MATLAB. We'll look at three types of functions. First, we'll look at built-in functions, then user-defined functions, and then anonymous functions. Let's look at those in order. We'll start with built-in functions. So you can think of built-in functions as black boxes in MATLAB. A black box, as you know, is something you input something to a black box and you get something out. You don't know what's going on inside of the black box, but you know that when you input something, you get something else out. So an example of that in MATLAB is the square root function, sqrt. You don't need to know what's going on behind the scenes in MATLAB, but you do know that when you give it an input, 9, you get the square root of that input, which is 3. So in MATLAB, when you write it, a script, for example, you might start with clear, close all, CLC, and then type x equals sqrt of 9. Then the value 9 goes into this function, into this black box. MATLAB does its operation inside of that black box and then outputs into your script, saved into the variable x, the value 9, the square root of it, 3. Another function that is commonly used in MATLAB is the linspace function. Linspace, though, takes 3 inputs instead of 1, and then outputs 1 vector. An example of linspace using 3 inputs are 0, 10, and 6. So in this case, MATLAB is going to create a vector that starts at 0, ends at 10, and has 6 elements. These inputs are put into this black box built-in function in MATLAB, and then MATLAB will output this vector 0, 2, 4, 6, 8, and 10, which will then be saved into your variable x. So if built-in functions are like black boxes, then user-defined functions are when the blackness begins to fade and you can create whatever you want inside of your function. So you know what's going on inside in user-defined functions because you're making it. So let's look at how we create a user-defined function. In MATLAB, you can press File, you can press New, Function, and function will come up. It starts with function, and then you list your output arguments in square brackets. If you have more than one, they can be separated by commas. And you set that equal to a function. This func is what you name your function. And then your input arguments. You would more than likely have more than one input arguments, though you could have just one. And you list them here in parentheses, separated by commas. Then you perform some code, you write some code to perform some operation on your input arguments and save them into your output arguments, and then you write end. So you have your input arguments going into your function, and coming out are your output arguments. Here's an example built-in or user-defined function for calculating the terminal velocity of a falling object. In this case, you take as inputs mass and the lumped drag coefficient, which we're just going to call CD. The output for this function will be v, that's the terminal velocity. And inside the function, it's quite simple. You set g equal to 9.81, and then you say v is equal to the square root of mass times g divided by CD. Now, any mass you input and any lumped drag coefficient you input will be put into this function and calculated for the terminal velocity, and that will be outputted as v. So you would need to save this file as vterm.m because your file name needs to match exactly the name of the function. So let's show a script, an example script, where we would call this function. Of course, you might start with clear, close all, CLC, just to get on a clean slate. And then maybe you would set your radius r equal to 0.1, and then do a quick calculation for the lumped drag coefficient. Here it's called lumped underscore drag. You see the calculation there that uses R. And then you call your function vTerm with two inputs. Here your first input is CD, or is mass rather, which is 20 kilograms. And then your second input is the lumped drag coefficient, which in the function is referred to as CD. When you call vTerm with 20 and lumped drag, those become mass and CD inside of the function. And then V is outputted and then saved in your script as VT. You might then save or display VT. This display VT will just display the value that was calculated in your function. Then you could save this script as vscript and just make sure that vscript and vterm, your script and your function, are saved in the same folder. Now, if user-defined functions look something like this, an anonymous function is much smaller. You can think of an anonymous function as an equation, really. In a user-defined function, you might do something like display to the screen, or you might print something or do a plot. In the anonymous function, you're saving just an equation. So here you have an input and an output. If you remember before your vscript.m and your vterm.m, this is the script in the function that we talked about previously. Here's a different script that uses vterm, the function, and an anonymous function. So let's start at the beginning, clear, close all, CLC. Then we'll have R, we'll set the radius, and then we'll define our anonymous function here. LD is at, first you say the at symbol, and then in parentheses, separated by commas, you list all of the variables in your function. So here, P for row, D, and A. And then you type your function, your equation. P times D times A divided by 2 is the equation for lump drag coefficient. Then you could call your anonymous function LD using this here, giving it inputs. Your inputs P, D, and A are 1.22, 0.5, and then pi r squared for the area. This, of course, will calculate LD based on the equation above and save it into lumped drag. And then you can use that lumped drag for the user-defined function vterm and then display VT. So just in summary, 3 types of functions. A built-in function is like a black box. A user-defined function is very similar, except you get to make the code. And then anonymous functions are like equations, very simple.